Welcome back to another episode of How to Algebra, where I show you the fundamentals of algebra. In this particular video, we're looking at the rational zeros theorem. If you followed the videos so far, there is a very progressive steps into analyzing any polynomial. So this is just the next step in line. So hopefully you get something out of it. If you haven't done so already, please subscribe, like, comment, let me know what you think. As always, let's get it. All right, so the rational zeros theorem. Okay, so leading up to this, it's worth noting that if you've been following my videos, there's a progression, right? Learning how to factor a polynomial, then dividing the polynomial, what it means for a factor to divide a polynomial, right? If you're given the factor, then you can divide it and analyze what the remainder is, and it can tell you if it's whether it's a factor or not, or like it's a solution, a root where it crosses the x-axis, if that's the case. And if the remainder is not zero, well, then it doesn't interact with the x-axis at all, right? But in the previous videos, we've been given a factor. Now, the question becomes, well, what if I'm not given a factor? Like here, all I'm given is a polynomial. And I want to find the factors. I want to find the zeros like from scratch, basically. Now, I'm not going to insult your intelligence. I'm sure you could read this. But what you need to understand, right? Like reading it is one thing, but being able to apply it and understand what you're reading, and math can be very technical when it comes to definitions and the way things are explained, right? Like this is a theorem that's written very elegantly, so to speak. So in layman's terms, in other words, what this is saying is that you give me any polynomial and I can take the factors of the constant and put those factors over the factors of the leading coefficient, and I'm going to make a list, right? Because right now, I don't have any idea what possible factors or possible roots this could be, right? My number bank to choose from is negative infinity to infinity. Like some number between negative infinity and infinity is going to work. And it's like, well, how do I know which one or where to even start? Well, that's where the rational zeros theorem comes into play. So I take the factors of 8, even though it says negative 8, right? Even though this constant is negative, I'm just going to take the factors of 8. So 1 and 8, 2 and 4. These are the only ways, not the only ways, but these are the common ways of making 8, right? Multiplying 8. Then you take the positive and negative version of each of these numbers. I'm going to put them over. So I guess it is worth mentioning that the constant, we label that P. The coefficient of the leading term, we refer to this as Q. So what we want is P over Q, right? The factors of 8 over the factors of 1. So the leading coefficient is 1. So that means 1 times 1, or negative 1 times negative 1. So here is P over Q, all the P's over the Q. So now what I want to do is take every combination of the numerator over the denominator. So what am I saying? I'm saying that 1 over 1, right? 1 over 1 is just 1, plus or minus, right? Because if I take negative 1 over negative 1, that's positive. If I take negative 1 over positive 1, then that's a negative 1. So in short, you take the fraction numbers and then you just throw a plus or minus sign in front of it. Okay, the next iteration would be 2 over 1. 2 over 1, that's just simply 2, plus or minus. 4 over 1, so plus or minus 4. And then 8 over 1, plus or minus 8. So what we've done is we've taken negative infinity to infinity, right? Every number in the world. And we've narrowed that list down to these 8. Positive 1, 2, 4, and 8. And negative 1, negative 2, negative 4, negative 8. So one of these 8 is guaranteed to cross the x-axis. It's like, well, how do I know that? Because the degree is 3. Any odd, right? Any odd degree has the end behavior, and this one's positive, so it's going to come up from the left and rise to the right. Now, in the middle, we're not exactly sure what happens at this moment, but I do know that for a fact, this must cross the x-axis at least once. At least once. I'm not connecting it because I don't know if it doesn't cross the x-axis or maybe, right? So our two scenarios is that it doesn't cross, like this, it doesn't cross, or maybe it gets really close and it bounces, or it does cross. Right, these are our scenarios. So let's do synthetic division using one of these, and it's basically using trial and error. There's really no fast way of doing this. So I'm just going to start with 1. I grab the coefficients. They are in descending order. So 1, so 1, 3, negative 6, and 8, negative 8. Okay. Bring down the 1 times 1. I add. So 4 times 1. I add. So right here, I can already look ahead and see that this isn't going to work out. Right, so maybe you didn't see it. 1 times negative 2, negative 2. When I add this, this is going to be negative 10, and it's not a 0. Right, so positive 1 does not work. Let's try negative 1. Negative 1. Getting the coefficients, 1, 3, negative 6, negative 8. So bring down the 1 times negative 1 plus 3, 2 times negative 1 plus negative 6, negative 8 times negative 1 is positive 8. So this is 0. So definitely, without a doubt, x equals negative 1 is a root. That's what we just found out. So now we need to figure out the other zeros. Now, I know that this is, since it was a third degree polynomial, we decrease it by 1. So x squared plus 2x minus 8. So x squared plus 2x minus 8. Now, the idea is that this is either not going to factor or it will factor, and the factors will either be real whole number solutions, or we can use the quadratic formula and maybe they're real and maybe they're complex, right? Maybe they're complex. So let's see. Multiples of 8 that add up to 2, negative 8. So 1 and 8, 2 and 4. So I can definitely make a 2 with 2 and 4. Because it's negative, one of them has to be negative, and because this number is positive, that means the big one is positive and the small number is negative. So 2 and 4, the small one gets the sign, right? Big one gets the sign of what's up here. So that's plus. So x, x. Okay. Since it factored, my roots are going to be x equals -2. Actually, x equals +2 because you set equal to 0 and basically you flip the sign. And x is equal to -4. So the three roots are as follows. -1, 2, -4. So what this is saying, so the picture's kind of off. So what's happening is that, so -1, -4. So it comes up, comes down, back up. So at -4, -1, and 2. It's kind of interesting if you ask me. Okay, let's look at another example. Okay, I want to take the factors of 6, right? Because this is my P. Coefficient's 3. Call this Q. And I want P over Q. And this will tell me all the possible factors, right? It doesn't guarantee me a factor, but because it's a third degree polynomial, right? And it's odd, then it's guaranteed to have at least one. Okay. So making 6. 1 and 6, 2 and 3. All of these are plus or minus. Okay, factors of 3. 1 and 3. Okay, we take every combination. So plus or minus 1, plus or minus 2, plus or minus 3. Right, these are all over 1. They're whole numbers. And then plus or minus 6. Because we have a second denominator, we actually have more numbers, right? We have 1 over 3. So plus or minus 1/3. 2/3. 2 over 3. 3 over 3. But 3 over 3 is just 1. So it's already in our list. And then 6 over 3 is 2. Again, that's already in our list. So here's our list of possible numbers that we can use for synthetic division. Kind of want to try the fraction on this one, right? Most people would be scared to use the fraction. I kind of want to just use the fraction. So let me show you how that would look. I'm going to use 1/3. So then I look at the polynomial. So 3, 2, 1. So all the x's are there in descending order. So 3, -4, -17, and then 6, plus 6, right? Okay, let's bring down the 3. I got to multiply by 1/3. So 3 times 1/3. The 3's cancel, making a 1. You can check the math on that. Pause the video if you want. Add. So this is going to be -3. Again, times 1/3 will be -1. Plus -17 gives me -18. Times 1/3, or divided by 3, really, will give me -6. -6 plus 6 will give me 0. So this means it is a factor. So x equals 1/3 is 100% a factor. Okay, let's try to find another one, right? So this would be x squared. This would be x. 18 times 3. We could use the quadratic formula, or we could pick a number and just keep going. I'm not going to use 1, only because I know where this goes. So if we use 1, 1's not going to work out. Or -1. Just spoiler alert. But if you don't believe me, you can try. So let's start with 2. I'm not too sure if 2 works. I feel like -2 is going to work. 2 might work. Well, let's go with negative 2, and let's just see what happens. Right, mix it up a bit. If I bring down the 3 times negative 2 gives me negative 6. When we add, we get negative 9 times negative 2 is 18. And look at that. We get a remainder of 0. So, again, it's a factor because the remainder is 0. What's a factor? Negative 2, right? X minus 2 is a factor. Or x plus 2 is a factor. X equals negative 2 is a solution. So this means that it was x squared. We decrease it by 1. So x, basically. So 3x minus 9. Now, could we do synthetic division again? Yeah, we could. However, 3x minus 9, that's nice. Because when I set that equal to 0, we're going to get 3x is equal to 9. We add 9 to both sides. Divide both sides by 3. X is equal to 3. That's our last factor. So there's definitely 3 real roots. Negative 2, 3 and 1/3. 3 and then 1/3. Okay, let's get to the last example. I'm already not liking this one. Okay, let's look at the possible zeros. So P is going to be 1, 2, 3, and 6. All plus or minus. Q, which is 4, is going to be 1 and 4. And then 2 and 2, right? 2 times 2. And again, these are plus or minus. Okay, our list is going to be kind of lengthy. So we have 1 over 1, so plus or minus 1. 2 over 1. 3 over 1. 6 over 1. Switch colors. So 1 over 2. 2 over 2. That's just 1, so I don't care about that. 3 over 2. 6 over 2. 6 over 2 is 3. It's already on our list. All right, last but not least. 1/4. So plus or minus 1/4. 2/4, which is 1/2. I don't care about that. 3/4. And then 6 over 4, which is 3/2. Again, that's on our list. Okay. I haven't worked this out. I haven't looked at the key. I don't know what's going to happen. So let's just start going down the list. See what happens. So 1. Start with 1. All the variables are there in descending order. So I'm going to grab the coefficients. Negative 13, 28, negative 6. Okay. Bring down the 4 times 1. Add negative 9. Negative 22. This is negative 22, which is positive 6. Oh, wow, 1's about to work out. That's crazy. 1 works out. Okay, so we got lucky. X equals 1 is a factor, unless my math is off. So if this is x to the 4th power, we know that this is going to be x to the 3rd power. I kind of want to just put the variables and then use factor by grouping. But let's just keep using synthetic division, see what happens. So if I use negative 1 now, this is going to be negative 4, negative 13, positive 13, negative 9, so positive 9. All right, negative 1 doesn't work. Negative 1 doesn't work. Let's try 2. Bring down the 4. 2 times 4 is 8. Negative 1. Negative 2. When you add, this ain't going to work. Right? This isn't going to work because this is going to be negative 24 times 2. That's not right at all. So 2 doesn't work. What if, let's try negative 2. So negative 2 times 4 is negative 8. This would be negative 17 times negative 2, negative 34. No, positive 34. Right, positive 34. So when you add, this is going to be 8 plus 4, 8, 9, 10, 11, 12. Positive 12. Which times 2 is going to be way more than 6. So this doesn't work either, is what that comes down to. So, and I bet it's one of the fractions. Let's go to 3. 3 doesn't work. Negative 3 doesn't work. I'm going to skip and use 1/2. But what if 6 works? Let's see. It's not going to work. Right, there's no way. Try negative. That's not going to work either. So negative 6 doesn't work. All right. We're getting there. 1/2 and 1/4. Want to try a 4th? Let's do a 1/2. Even if I did negative 1/2, that wouldn't work because we're going to hit a fraction right here. And we need a whole number. 1/2 ain't the way. It's not the way. Okay, let's try 1/4. Bring down the 4. 4 times a 4th, which is 1. That's nice. When you add this up, negative 8. It's looking good. Times a 4th. So negative 8 divided by 4, negative 2. Plus negative 22. You get negative 24. Divided by 4 is negative 6. And haha, we get one of the zeros. So this is x equals a 4th. We know is a factor. Okay, so let's see. X to the 4th, x cubed. So then this is going to be x squared minus 8x minus 24. Okay, so let's think about this for a second. 24 times 4, 96. Multiples of 96 that add up to 8. I feel that's doable. I feel that is doable. But let's see. So 1 and 96, 2, 3, 4. What's that? 4. It's going to be 1. No. 2. 5, 6. All right, so 6 is going to go 1 time. And then 6 into 36 goes 36, right? 6 goes into 9 once, 3 left over, 36. Okay, so 6 and 16, getting close. 8. So those didn't work. 8 goes in 9 once, and then twice, right? Because 16. So is there a way to make an 8 from 8 and 12? One's got to be negative. Okay, so without spending any more time, quadratic formula is the way. So A, B, C. So minus B in this case, negative 8, plus or minus square root B squared, so 64, minus 4 times A times C, which is negative 24, all over 2 times A, 2 times 4, which is 8. Okay, we're going to get, so simplifying this, we're going to get positive 8 plus or minus. So 4 times 24 we know is 96. Times 4. 4, 8, 12, 16. So 400 minus 16 is going to be 384. I feel like it's 384. So 64 minus, well, negative and negative is a positive, 384. All over 8. Okay, so what is this? 38, 39, 40, 41, 43, 44, 44, 44 plus 4, 448. 448. So plus or minus 8. No, not plus or minus 8. It's positive 8 only. So just 8 plus or minus root 448 over 8. 448 a perfect root? That's the question. Okay, so 448 is not a perfect square. However, 448 can be factored. 8 plus or minus 8 root 7 over 8. So those are going to cancel. And the root is going to, the two roots, real roots in this case, are going to be 1 plus or minus root 7. So x equals that. Or x equals those. Okay. So fourth root polynomial, fourth degree polynomial had 4 roots, x equals 1, x equals 1 plus root 7, 1 minus root 7, and x equals 1/4. Okay, so this was the rational zero theorem. In summary, when you're given a polynomial, you can factor it by taking the factors of the constant, factors of the leading coefficient, put them over one another, specifically the factors of the constant over the factors of the leading term, and choose from that list, right? Choose from that list of rational numbers, right? Rational numbers would be a fraction. So hopefully this helps out in understanding how to use the rational zero theorem. All right. Please like, comment, subscribe. You know the deal. Catch you in the next video.